Welcome to all. This is my channel. All are welcome to subscribe my channel. Today we are going to discuss about chapter 6, 11th CBSE chemistry. The first question is, choose the correct answers. A thermodynamic state function is a quantity. Option 1 is used to determine heat changes. Option 2, whose value is independent of the path. Option 3, used to determine pressure, volume, work. Option 4, whose value depends on temperature only. So the answer is whose values depend on the path, because the reason is functions like pressure, volume and temperature depend on the state of the system only, not on the path. Then students, next question is, for the process to occur under adiabatic condition, the correct condition is del T is 0 or del P is 0 or Q is equal to 0 or W is equal to 0. So always Q is equal to 0, because for an adiabatic process heat transfer is 0. Therefore Q is equal to 0. Then the next question is the enthalpies of all elements in the standard states are: option 1 unity, option 2 0, option 3 less than 0, option 4 different for every element. The answer is 0. Students, next question is, a reaction A plus B gives C plus D plus Q is the found to have a positive enthalpy changes. The reactions will be possible at high temperature or possible only at low temperature, then not possible at any temperature, finally possible at any temperature. So 4 options are given. The correct option is possible at any temperature. The next question is, in a process 701 J of heat is absorbed by a system and 394 J of work is done by the system, what is the change in internal energy of the process? So the answer is, as per thermodynamic first law, internal energy del U is equal to Q plus Wi. So internal energy is equal to heat, W is equal to work done. So both are given. So 701 plus negative 594, that gives negative 307 joules. Here it is 594. The next question is given N2 gas plus 3H2 gas gives 2NH3 gas. So del R H naught is equal to negative 90.4 kJ moles inverse. What is the standard enthalpy of the formation of NH3 gas? The answer must be standard enthalpy of formation of compound is the enthalpy that takes place during the formation of 1 mole of substance in its standard form from its constituent elements in their standard state. That means dividing the chemical equation given in the equation by 2, we get 0.5 N2 gas plus 1.5 H2 gas gives 2 NH3 gas. Therefore, standard enthalpy formation of the ammonia gas 0.5 multiply with negative 92.4, that gives negative 46.2. The next question is a reaction A plus B gives C plus D. Q is found to have a positive enthalpy change. The reaction will be, first one is possible at high temperature, second one is possible only at low temperature, third one is not possible at any temperature, and fourth one is possible at any temperature. So fourth one is correct, because for a reaction to be spontaneous, del G should be negative. So del G is equal to del H minus del AS. According to the equation for the given reaction, del S is positive. So del H is negative. Since heat is evolved, del G is equal to negative. Then the reaction is spontaneous at any temperature, hence alternative fourth one is correct. Student, next question is for an isolated system, del U is equal to 0, what will be del S? Del S will be positive because greater than 0. Since del U is equal to 0, del S will be positive and the reaction will be spontaneous. Next question for the reaction 2Cl gas gives Cl2 gas. What are the sign of del H and del S? So del H and del S are negative because the given reaction represent the formation of chlorine molecules from chlorine atoms. Here, bond formation takes place. Therefore, energy is being released. Hence, del H is negative. Also, 2 moles of atoms have more randomness than 1 mole of the molecule. So, spontaneity is decreased. So, del S is negative for the given reaction. The final question is, the equilibrium constant for reaction is 10. What will be the value of del G power Q, power theta? R is equal to 8.314. JK inverse 1, moles inverse 1. T is equal to 300 K for the expression. Del G power theta is equal to minus 2.303 RT log K equivalent. So del G power theta for the reaction 2.302 multiply with 8.314 JK inverse mole inverse, because R is 8.3 and T is 300K and log 10. So altogether we get negative 5.744 kJ mole inverse. Thank you very much.